quotient rule of exponents. If m and n is a positive integer and a is a real number, then a to the m divided by a to the n is a to the m minus n. What this rule says, if you are dividing the same base a, then you keep that base and subtract the exponents. For example, if we have 3 to the 4 divided by 3 squared, then we know that 3 to the 4 is 3 times 3 times 3 times 3, that's 81. And 3 squared is 9, so when you divide that, you get 9. Let's use this quotient rule instead. So you divide the same base, 3, you keep that base, and you subtract the exponents. So 4 minus 2 is going to be 2. And 3 squared is 9. So you see how that quotient rule works for exponents here. Let's use this rule to simplify expressions. Our first example, we have a quotient here. And if you think about it, 9 is actually 3 squared. So you could rewrite it like that, or you could just simplify the number factors. Either way is fine. But let's say I just rewrite that as 3 squared. And then I can use the quotient rule here. So let me start with base 3. I have the same base, and now I'm going to subtract the exponents. Remember, 3 does not have an exponent, so it's automatically an exponent of 1. So that'll be 3 to the 2 minus 1. Base a, I'm going to use the quotient rule here. So the numerator exponent of 4 minus the denominator exponent of 1, because there isn't one. And now base b, I'm going to take the numerator exponent minus the denominator exponent. Now let's simplify all of those differences in the exponents. So 3 to the 2 minus 1 is 3 to the 1. A to the 4 minus 1 is a to the 3rd. And b to the 7 minus 2 is b to the 5th power. And that is as simple as it gets. Our second example here, let's say we rewrite 8 as 2 to the 3rd power. Oh, no, I don't want to do that because then I'm going to have to talk about a rule we don't have yet. So forget that. Let's keep it as 2 and 8, and we'll simplify it that way. So remember, 8 is 2 times 2 times 2. Okay. So now we can divide a factor of 2 from the numerator and from the denominator. And that means we still have 2 factors of 2 in the denominator. So 2 times 2 is 4. Everything else is staying the same. So now I'm going to use the quotient rule for exponents. And the only quotient I have is x, right? Everything else is going to stay the same. So I need to take the numerator's exponent minus the denominator's exponent for that base x. So 9 minus 5 is 4. And everything else remains the same. The zero exponent rule. If a is a real number, not 0, but any other real number, then a to the 0th power equals 1. And 0 doesn't work because 0 to the 0th power is undefined. It's not 1, but we won't need to worry about that because we won't have that in any of our examples. So why is this zero exponent rule true? Let's look at an example. A to the 4th over a to the 4th. So a to the 4th means a times itself 4 times, right? And same thing in the denominator. So if we were going to simplify this expression, then we can divide any factor from the numerator that's also in the denominator, right? So a divided by a, that's 1. A divided by a, that's 1. and so forth. That's just 1. So 1 times 1 times 1 times 1 equals 1. What if we used the quotient rule for exponents? If you divide the same base, you keep that base, and what do you do with the exponents? You subtract. So 4 minus 4, that gives you a to the 0th power. We already know that this expression equals 1, so that is why a to the 0th power, or any real number to the 0th power, is 1. So let's use this exponent rule to simplify expressions. So 5 to the 0th power is 1. XYZ cubed to the 0th power. I know that's just going to be 1, but what if you use a product to a power rule? So each factor of the product gets that power. So x to the 0, y to the 0, and z cubed to the 0. Okay. Let's simplify. X to the 0 is 1. Y to the 0 is 1. And here with the base z, we've got a power rule, so we'll multiply those powers. And we know that z to the 0th is still 1. So 1 times 1 times 1, yeah, that's 1. Any base raised to the 0th power is 1. How about this last example here? Negative x to the 0th power. What's the base of 0? 0 is only touching the x. So the base x to the 0th power is 1. But there's a negative that's not part of the base, which is in front of that. So that means that negative x to the 0 is negative 1.